Welcome to the React Universe on Air, brought to you by Callstack, a total software engineering consultancy. My name is Jakub, and I am your host during this coffee talk. And this is exciting because I've got my special guest here with me, Marc Rousavy. Hi, Marc. How you doing?
Hey, what's up? I'm good. How are you?
Marc is joining us because there was something. I can say it's something big that happened. This guy is responsible for it, and he will tell us a bit more about it. But before we jump to the sauce, I know that, not too long ago, you've been on some holiday, you've been traveling, tripping. How is that going? How was that?
It's amazing. I took some time to relax. I took some time to get my mind off of work, and now I'm back. It's always like these 1 week blocks. So yeah, I've been in Poland here as well. Just not a month ago or something. For the conference, for the React Universe. So I've been kind of everywhere.
Awesome. Kind of jealous because I've been working hard recently, and I'm looking forward for this Christmas break already. But it's still a little far away. But
I think it's funny that there's like so many holidays in winter because people were like back in the days they were kind of so depressed in winter because they couldn't do anything, so they invented all of those holidays.
What do you mean they were depressed? There still are.
Yeah, they still are. Yeah, but at least not as much as back in the day, I guess.
Yeah, I think we should be inspired by those people,
Yeah,
let's take a break. Yeah, man. That's how I'm usually a bit confused and a bit funny when I hear that, in the UK, the snow fell and all the schools are closed and there's like snow this much. I'm like, what do you mean? What do you mean there's a lot of snow and it's closed? What?
But it surprised me that you don't get a lot of snow in Poland, right? Because Mike told me you don't really have that much snow.
Yeah, it's been better years ago, but with the climate change and everything, it's just sometimes you get a full month of snow, but sometimes it's just like 2 days and it's gone and it's just gray everywhere. So, But you know what? Let's stay positive because we are not here to talk about depression and snow, but something more cheerful. So on 13th of September, you have released Nitro Modules to the public.
Yeah, Friday 13th.
Yeah, so that was very brave. Any issues with that?
No, actually, no. It went great, which was surprising, actually.
Okay, you're either a wizard or you're a liar. One of two. Okay, so before we jump into what Nitro Modules actually is and how to use it and why to use it, what inspired you to even start working on something like that? What was the day that you got inspired?
Well, I think it's not like a specific day where I just decided I want to build Nitro Modules. It's more like a, organic evolution of the stuff I do. So, I built Vision Camera. I built, some other libraries, React Native, MMKV. And then we started working on this 3D library for a client of ours. It's a Pengu app. And we built, we bridged Filament to React Native, to JavaScript. Filament is a Google 3D rendering library.
Okay.
So we created React Native Filament, and everything was built in JSI. And we quickly started to realize, okay, we can't write manual JSI all the time, especially for function calls, because calling JavaScript functions from native requires so much, code, so much boilerplate, so much thinking, because you need to safely keep a reference to the JavaScript function. You need to safely to this, to that, to the, it's just a bunch of overhead. So I decided to create a library which allows us to, build modules that are as powerful as, using JSI directly, but at the same time are easy to use and safe. And, they schedule stuff on the correct thread. They properly do memory management, so you don't have to do all of that manually.
Okay.
So yeah, that's how it organically, I guess, grew to me building this library, and then we shipped it in React Native Filament, and I decided, okay, now I want to extract it and allow other people to also build such great, libraries with this core foundation.
And that's the beauty of the open source, right?
Yes.
Okay, so that pretty much sums up what Nitro Modules really is. But if you could sell us, pitch the Nitro Modules, what it is. Now we know the story behind.
Okay. It's hard to put it in one sentence, but I think the main key points are, okay, we all know how to write JavaScript, but we need, platform access from time to time, or performance from time to time. Now, previously you could build this stuff with native modules, with Turbo modules, which are great, But at some point, you're going to hit limits if you're building, something that's not just typical, just a single function call. So if you need objects, if you need, instant like native objects exposed to JavaScript instances, if you need more control over function calls, if you need better events, if you need all of those kinds of things, you are just stuck with using JSI directly. And no one wants to use JSI directly in C++. Especially not if you have to bridge to Swift or Java then, because it's just so much effort, it's really, really complex. So this is where Nitro Modules comes in, and it's kind of like this framework to build native, in quotes, modules with more flexibility for those advanced use cases and more performance.
All right. So that kind of guards you from playing with JSI. So you will never have to play with JSI with using Nitro, or do you think there are some kind of exceptions that you will still have to jump in?
Well, there have been some people already who are working with Nitro modules. One of them is the maintainer from React Native Unistyles. And he actually had one use case that Nitro didn't solve. So, all of the other things we worked on together, we upstreamed it and now it works. But there was one specific case where we couldn't solve this with Nitro, and that was like a function. You needed a function where you have any type of argument. So it can be like 0 arguments or 100 arguments. So any type of arguments, variadic arguments plus variadic types. So in this case, it's just easier to use JSI instead of just trying to statically bridge everything. And the cool thing about Nitro is by default, it's, not using JSI. So in theory, we could swap it out with a different, interface in the future, like static Hermes interfaces, for performance, obviously, and the user doesn't have to change anything. But if you need to use JSI for this specific reason, for example, in this one specific edge case, then Nitro provides a single method for you called register raw JSI function. So you can interrupt into JSI at any point. So there's full, there's no limitation here.
All right. And the name of the function is very descriptive. Yes. Nice. You don't have to guess what it is.
Right.
All right. So now we know it. It's kind of a framework, right? So, many people listening to this or watching us on YouTube probably never had to build a framework. Or maybe they were like, I would love to build a framework, but that sounds like a massive behemoth to tackle. So how do you start building framework or something similar to framework?
So the name framework is, React Native defined the name framework in the React Native space, and Nitro technically is not a React Native framework.
Okay, all right.
Because I think for a React Native framework, you also need to have, maybe a CLI or something. I guess Nitro has a CLI, but bootstrap a template, do this, maybe some CI, maybe, I don't know what the exact definition of a template is, of a React Native template is. Okay. But it is not a React Native template. Framework, not template. Framework. But it is a framework. So just a traditional.
So it's not a React Native framework, but it's a framework.
A framework.
All right.
But yeah, it's a big project. So I guess to start, I guess it had to kind of grow inside this library we're building, React Native Filament. So you can't just really build it from scratch because you don't have any goal, you work towards. So you can't really start, okay, I want to make native modules better.
Yeah.
You have to have some goals, some examples, some use cases you want to solve, and then just work towards that goal by implementing, one by one.
This is very smart because it's like, if somebody would like to build a very accessible product, but they never spoken to a person who's got, I don't know, site, issues or something like that, and they're trying to figure out, maybe they will find this helpful or find that helpful. You need to have a use case, right?
Right.
You need to understand the problem.
Right. Yeah. That's. I guess it's the same in the product world, right? You need to kind of figure out who you're actually building for.
I mean, Nitro is a product, but for developers, really.
Right. Yeah.
Yeah. All right. So first step: have a problem to solve. Don't come up with the problem. Just have it.
Yeah.
Right. All right.
Yeah, right.
So then I have a problem in my head. So what will be the next step? Where do I start? I don't know, with the setup or if I start coding, should I just include my code in my project, or should I already extract it and build like it's a third party? I mean,
if you have a problem in your head, you should seek therapy, I guess.
I do actively.
Okay, so well, Are you saying about building it in an app first or extracting?
I'm wondering what's the best approach, because I can imagine most people would start building within the project as you did with Filament.
Yeah.
But does it introduce any issues later on when you want to extract it?
Yes.
How difficult it is to tackle these?
So I think all of my libraries were originally created as a library inside the app. So Vision Camera, for example, was for a startup I worked for 3 years ago. So they just wanted to have a better camera, and I built this as a library inside the app as a native module back in the day. Nowadays you could use Nitro in your app to build native modules, which is what me and Mike are doing. But yeah, so you first build it in the app because it's just, it's the use case you want to solve. You imagine you have the problem here in your app, so you want to solve it in the app. And then extracting later on is definitely difficult. It sucks because you have so many, it's like tightly coupled, right? So you need to decouple it from your app. Then I guess I think there is already a React Native library template. I'm not sure if it's published yet, but there was not. There was none like a few months ago or years. So it's also a bit tricky to set up libraries with the publishing flow, the npm publish flow, auto linking, so that it gets properly detected by the React Native CLI. You need to configure it, the React Native.config.js. Now you have the code gen config and package.json for Turbo modules. You don't need that for Nitro. For Nitro, you have a nitro.json, which is simple to set up. So there's like a bunch of stuff.
Proof.
Yeah. So there's a bunch of stuff you need to set up to publish it as a library. So I would definitely, if anyone wants to build a library, you should definitely start in your app first, because it's just so easy, and you can literally skip auto linking, right? Because your app starts with the app delegate or main application. You can just register your module there and not think about it. Yeah. And you don't have any builders, you don't have any module not founders. Just register it there and then build the module, and then later on figure out how to actually link the module.
Okay. Yeah, and it's a good way to think about good practices of programming, because if what you just mentioned, like decoupling stuff later on, taking care about configs and stuff like that. If you build the code having all these principles in your head, it's going to be way easier to extract this code later on, right?
Yes.
But yeah, we're all developers. We know how sometimes we write code. And okay. So with this kickstart for the framework build, I think we can encourage y'all to try it. Just have a real problem first. Awesome. So moving on, regarding Nitro modules. So I remember you were, we were discussing at some point after the conference. By the way, Marc had a speech at the React Universe, and you can check it out on YouTube as well. So coming back to the question, we were discussing Nitro modules, and you mentioned, difficult words like hybrid object or nitrogen or Nitro module as a library. I would like you to elaborate a bit more about that, because I've heard something, but our audience maybe is not aware of that.
Yeah. So I think I explained this very well in the documentation. But
which is pretty nice, by the way.
Yeah, we had a nice redesign. Did you see?
I saw that, yeah.
Amazing.
Like 3 days ago.
Yeah, we just launched it. So our designer, Lauritz, he just redesigned the whole page, and it looks so fucking sexy.
Give me his number, man.
Okay, so a Nitro module is what one. So there's 3 terms you need to understand. One Nitro module is one library. For example, React Native Vision Camera will be a Nitro module. For example, React Native Unistyles will be one Nitro module. And then Nitro modules is all about this object-oriented or instance-based approach, which, traditionally native or Turbo modules were not. You just have one function, you call it. It's like a static function. But in Nitro modules, you actually create an instance of your module first, and then you have those member functions on this instance. Okay. You could theoretically let's think about React Native device info, right? In this case, you only need static functions. That's why Turbo modules and native modules traditionally only use this, because it just made sense, or still does. So for React Native device info, you only have this method like get device name, get device IP address. But in Nitro modules, the goal was a bit bigger, right? Especially with Filament, for example, we have a buffer, we have a model, we have stuff we want to load. So for example, a filament view or a filament model could be animated, so you can call methods on it, and you have multiple filament views, multiple filaments.
Okay, I get it.
Yeah, so multiple instances of some native code. So each instance is one hybrid object. You can create it from JavaScript, and each hybrid object has methods on it and properties. So get set, which is also something that's pretty cool, I would say. And then the native methods, are just connected through JSI with this Nitro layer, which is very, very efficient. And on iOS, for example, it uses, the Swift direct interop, which is insanely fast.
Yeah.
So no Objective-C at all. So those are the hybrid objects. You create an instance of it in JS. Typically for React Native device info, for example, you only have one instance of the device info module.
Yeah.
But for filament buffers, for filament models, you have multiple instances. You can create them, and they can get also deleted if you don't use them anymore, which is good for memory, obviously. And each one has their own state. Each one has their own methods. It's exactly like a JavaScript class. You have multiple instances of it. Like you just do new, and you have methods and properties on it. So that's what a hybrid object is.
Okay.
But it's not in JavaScript. It's it's implemented on a native side in Swift or Kotlin.
Okay.
And then the third, term you would need is nitrogen, which is Nitro's code generator, named after nitrogen, the chemical compound. And nitrogen is used for or used only by library developers. So if you develop a library, use nitrogen to generate the native interfaces for, let's say, device info hybrid object, for filament model hybrid object, for camera hybrid object. So just the library developers. If you just use a library that is built with Nitro, you don't have to generate anything. You don't have any CLI. You don't have nothing. It's just a module that's already been shipped. That's it. There's no extra step for app users.
So we all know this process with this step, right?
Yes.
We just pull the stuff and it's just working, right?
It just works, yes. So library developers run nitrogen and they have this TypeScript interface. Let's say, for example, it's interface device info, and then it extends hybrid object. And in this TypeScript interface, you have a method like get device name, returns a string. Then you run nitrogen, and it just generates the Swift interface that you need to implement and the Kotlin interface that you need to implement.
Okay.
And then you implement get name, just return whatever you need with the native platform APIs. And then you can create instances of this in JavaScript. That's it.
So it gives you the whole boilerplate that you would have to deal with.
Yes.
Nice. All right. So 3 terms, and these are like the key terms that you need to be familiar with if you want to talk about Nitro modules. And the follow-up question, because you mentioned while talking about Nitro module as library, you mentioned that Vision Camera, for example, will be that. So obviously you will be bringing Nitro modules to Vision Camera. Does that mean a lot of work? Do you need to adjust stuff, and or is it just a drop-in replacement? That's it. Bye.
So because Nitro is such a fundamental, Nitro modules have such a fundamental difference to Turbo modules or Expo modules even. I would say it is a little bit of work you need to do because it just has different APIs. It's just a different interface. For example, in Vision Camera, I can drop so much code for the frame processor runtime because everything can be handled with Nitro. There's no need to interrupt with JSI or anything anymore. And that's like, what is it? Probably like maybe 20 files across iOS and Android that can just be removed because I can just build it with Nitro as a simple prop. So this is really, really cool.
Yeah.
And then I guess the methods can stay. I don't need to implement the camera encoding stuff. All of this stuff is obviously that stays. That's the native stuff. So it's just a binding layer you swap out. For typical libraries like device info, for example, I think it won't be a lot of effort. For Vision Camera, it might be because the frame processor runtime it just uses JSI so directly, and I need to kind of extract all of that or remove all of that now with Nitro.
Okay.
But yeah, typically it would be quite easy.
This part of code that you just mentioned would have to be then taken out from your JSI implementation and put into a Nitro module. Or
no, not really, because essentially there's just a lot of code that I had to do back in the day because Vision Camera was a Turbo module, which I don't need to do now anymore.
Okay.
There's just so much, it's hard to kind of explain that, but if you look at the code, if you look at the diff, you will understand, wow, this is really nice to use it like this.
Yeah. All right, I see that. Okay.
Because, one example would be like the frame processor receives a camera frame, right? So you receive an instance of a camera frame. With Turbo modules, that just was not possible back in the day. So I had to create a JSI host object, wrap the native platform frame in this, which is different on iOS and Android. It's different types.
Yeah.
So on iOS, it's a CM sample buffer. On Android, it's an image or something. And I had to wrap all of that, write the manual JSI code, And it's just a lot of effort to kind of bridge that to JSI. With Nitro, I can just make frame a hybrid object now, and then it's a Swift and Kotlin object, and I don't need to interrupt with JSI at all anymore.
Okay.
So it's a hybrid object, boom, done, call awesome. It, that's it.
So you're talking a lot about, JSI and that, you don't have to really deal with it after using Nitro modules and stuff like that. So, that basically touches on the very foundation of, React Native as well at this point. But do you have a feeling that maybe this part, the foundation, the native code, might have some breaking changes in the future? Is it stable, or do you feel like we should still be kind of cautious when using it because it's touching on those native parts?
You mean Nitro in general?
Yeah, in general.
Yeah. So I think someone on Twitter actually said this as well. Nitro might use some private APIs or something, which is not true. Nitro does not use any private APIs. It just builds upon JSI, which has been around and released publicly and shipped in React Native in production for many years now.
Okay.
And there have not been any breaking changes in JSI ever since it was released, I think. Unless I'm mistaken. I don't know. I'm not really aware of any of those breaking changes.
All right.
So Nitro Modules builds on top of JSI, and then there's no React Native dependencies apart from the entry point. The entry point right now is a Turbo module, which almost skips a few questions. But so the entry point of Nitro is a Turbo module to just get Nitro initialized into the JavaScript runtime that you're using in JS. That's it, right? So this is only one point. We initialize Nitro, and that's it. We can obviously, or theoretically, if you have some other runtime, like, I don't know, maybe you're running on desktop, maybe on Windows, maybe on whatever, or maybe even in a non-React Native environment, but you still have JSI, which is just it's a C++ interface built, which works on JSC, JavaScript Core, Hermes, V8. There's multiple runtimes that support it. So if you just have any JavaScript runtime that can interrupt through JSI, you can also use Nitro. So it's not specific to React Native, but I guess it will only be used for React Native for now.
Is the core platformness as its core, basically. All right, cool. So we can be safe about this C++ fundamentals. Don't really need to worry about. And you mentioned Turbo modules. Obviously, there is also something called Expo modules. So now with Nitro modules, what's the difference? Like, how do we compare these three?
So Nitro modules and Turbo modules, or native, like old architecture native modules, they are fundamentally different because Nitro modules just use this hybrid object approach. So you have an instance-based approach. You can create instances of it. It's memory managed. It probably has a memory size. It even has a prototype in JavaScript, so it even supports inheritance, which is really, really cool in my opinion. So you can have, like, for example, a frame in Vision Camera could extend a common image type, so you could theoretically even render a frame if you wanted to.
That's sick.
So extending this inheritance would be really cool. We just shipped it actually yesterday.
Oh, really? Yesterday?
Yeah, I just did the commit yesterday.
Damn.
Or 12 hours ago, so it was midnight.
Okay.
And yeah, so it's fundamentally different. It also uses Swift only, and it does not go through Objective-C, which is experimental technology is what Apple calls it, but it's working for us in production. And there are obviously some developer, like, for example, it increases your build time a little bit if you use the Swift intro, but at the same time it speeds up the runtime performance by so much that I think it's worth it. And so just maybe a little bit of context because I didn't explain it very well, but you write Swift code. And traditionally, if you write Swift code in a Turbo module, you have to set up your Objective-C code first because it goes from JavaScript to C++, which is JSI, and then to Objective-C, which is what Turbo modules is about, okay?
Yeah.
And then in Objective-C, you can manually bridge to your Swift code if you want to. This is also what Vision Camera uses because Vision Camera is in Swift as well. So it goes Objective-C first and then Swift. And Objective-C is a dynamic dispatch language, so every method call is a little bit more dynamic than it would be in Swift, for example, where it's just a static method call.
Yeah.
So there is a little bit of an overhead involved. Objective-C is fast, but it can be faster, So I guess calling Swift methods is faster than calling Objective-C methods. So yeah, and Nitro builds on this new technology that Apple released 3 months ago, which is Swift and C++ interop. So you can directly bridge Swift to C++, directly, connecting the symbols. No Objective-C involved at all. No dynamic message sends, no dispatches, no nothing. Okay. So it's just C++ straight to Swift. We did some benchmarks, and I compared it's a very niche benchmark, so there's not enough. It's not a real world use case, but just a simple benchmark to call a simple native function. I called it add numbers, so it just adds 2 numbers, A and B, and returns the result to JavaScript. Okay, so I benchmarked this Nitro versus Turbo versus Expo, and Nitro was 15 times faster than Turbo Modules. 15 times.
Nice.
So by a lot than Turbo Modules. And Nitro was, I think, 59 times faster than Expo Modules.
Damn.
So for this specific benchmark, it was like a lot faster. Like it's insane speeds. This is obviously just a bridging layer, right? So the bridging layer is faster. The native code you write is obviously the same, but the bridging layer is faster. Which I think is really, really cool. And as to answer the rest of the question, Nitro Modules compares to Expo Modules in a way that it's very similar, but still fundamentally different, because Expo Modules, for example, does not have a code generator. Nitrogen does, or Nitro has one. So you are always in sync with your native types. You cannot build your app if you're not following the TypeScript specs that you generated. So you don't have any undefined errors. You don't have any wrong type errors. It's just always in sync.
So for the example of people who are maybe not familiar with code gen and stuff like that, it's kind of like if you're a front-end developer, you probably know the situation where you get the API with some endpoints and types there, and then sometimes you have to do it manually, rewrite all those types in your front end, but sometimes you get some kind of library that can basically take those endpoints and generate the code for you on front end, like with the definition of the endpoint, with types and stuff like that. So this is kind of this, but on like a lower level for
it's a lower level, because you like it's like it's generating those native interfaces. You cannot build your app if you don't follow along these interfaces. So there's no way, unless you don't rebuild your app, which would, be very weird if you make a native change. But if you rebuild your app and the app builds, then you're following along the interfaces that you created. So it's always the source of truth, which I think is really good. So now you cannot get any undefined errors anymore from, or wrong type errors from a Nitro module. And Expo does not have one yet. I don't know if they plan to add one, but right now they don't. The API is very different. So there's some, I even have a doc in the documentation that compares those libraries.
Okay.
The API is a bit different because, just one specific example, in Nitro, every function is synchronous by default. Okay, so if you call it calls it on a JavaScript thread, and then you have to return a value. If you create an asynchronous function that runs on a separate thread, still gets called synchronously, but you return a promise, and inside this promise you can run asynchronous code. Exactly like the JavaScript API. You return new promise, and then you have resolve and reject, right? So this is exactly like JavaScript. This is how it works in Nitro.
Okay. So it's a promise created by Nitro, returned to JavaScript.
Right. You create a promise first, return to JavaScript, and then you can, on a separate thread, resolve it or reject it. In Expo, it's a bit different, because you either create function or async function. So you're not creating the promise yourself. You just have function or async function, and then it's either sync or async. I'm not sure if you have control over which thread it actually runs on, but anyways, those are just some minor, developer experience differences. Whatever you prefer, I would say, is the better option, But yeah, so there's some differences. Is there something else I can think of? Maybe, Nitro Modules has properties, and Turbo Modules does not have properties, so you only have functions. In Swift and Kotlin, you have a property with a getter and a setter. Just one other detail I can think of. So there's a doc in the documentation. If you want to compare them, I recommend you check it out. In the Nitro Modules documentation, there's a comparison with other frameworks.
All right. And so following up questions, because you mentioned benchmarks for this add function. Somebody on Twitter was asking, what's the benchmarks for Android then?
Oh yeah, I didn't create Android benchmarks yet. But on Android, there's so Okay, so on iOS, there's a lot of points where I made performance gains in Nitro Modules. A lot of optimizations went into this. Starting from this chain, right? We're going from JavaScript to native. Starting from this chain. In JavaScript, we optimized it by lazily loading all the modules, by keeping them in memory, by not doing anything dynamic. Then on the C++ layer in JSI, I optimized it by using native state. That's different. Like all the other libraries don't use native state; they use whole subject right now. I cached all the props in the prototype. I did this, I did that. Some bunch of caching. Then a little bit lower on the parsing argument side in C++. Everything is statically generated because of the code generator. Everything is a C++ template, which if you know C++ is pretty cool because it's also type safe at compile time.
Yeah.
And it's just one path an argument has to go through. So there's no like runtime type checking. It's only casting it to this value. And if the cast does not succeed, it throws. But there's no like, is string, is number, is this, is blah, blah, blah. It's just, I know we want a number. I'm going to cast it to a number. Only if it fails, then I throw an error. Otherwise, I'm just going the fast path.
Very straightforward, yeah.
Right. Then the Swift path on iOS is very, very direct. So it's using direct, Swift C++ interrupt, which is where we also gained a lot of performance gains. On Android, we have the same optimizations on this side, but we don't have the Swift optimizations because we're using, we're not using Swift, we're using Java or Kotlin. So we couldn't optimize this part a lot. It's still, Java uses JNI, dynamic method invocations. So there's not a lot we could optimize. But I'm still 100% sure that it's, faster because of all of those optimizations that went into the first part. So I will create some benchmarks to just see how much faster it is actually. So we know, what we're dealing with. But yeah.
All right. I want to see some benchmarks for tvOS because that's my reality recently. All right, so let's step back from those technical details a bit because, we're still in a technical area, but I wanted to ask you, if you could share a bit of light on the development process of Nitro Modules. Like, did you have any unexpected challenges or those so-called aha moments where you were like, I was thinking about it for a long time, and this is a solution that's simple enough?
A lot, actually.
Yeah.
So it's just a few examples. Okay. So I found out how JS prototypes actually work. So inheritance in JavaScript is a bit more hacky than it is in other languages.
Yeah.
So I found out how that really works and how to make that really efficient.
Every JS developer is thinking now, I need to do that as well. Prototype, what the hell is this?
Yeah, you don't need that a lot.
Yeah.
Luckily. What else? C++ templates. I wrote some C++ templates before, but not to that extent. So if you look up C++ templates, trust me, it's tricky. It's really tricky.
Oh, really? Something in C++ is tricky? What?
No shit, right? So yeah, C++ templates. We have this, or I have this module or this class in Nitro which can convert any value to a C++ value, any JavaScript value, and you can extend it, and it can throw errors, and it can tell you if I can convert it, if I can't convert it, you can convert it back, you can convert it to it. So like a lot of flexibility with C++ templates. It's much more powerful than generics in Swift. Much more powerful than generics in Java because generics in Java are just objects. So it's just a hacky implementation. And obviously much more powerful than TypeScript, any type. So in C++, you can really, you can conditionally compile code. You can have, for example, an if branch saying, if this method returns a void, then I will not allocate a return type. So there's so much control you have over this because a template is essentially just duplicating the code across different types. So this was really cool and really, really cool to kind of, have more experience with C++ templates and figure out how all of this really works. And then the most, or the biggest aha moments and the biggest gotchas I stumbled upon was the C++ and Swift interrupt, which is, there's one doc in the documentation about it.
You mean in Nitro documentation?
No, in the Swift documentation to deal with C++ and Swift interrupt. But, to actually use it, you need so much time. You need to really play around with it. I found out that, for example, Swift generates a header for you. We all know this --swift.h header. But this header can contain bugs. And there's
the auto-generated one.
And there's no way to hot patch it because it gets generated on each Xcode build. There's no way to fix those errors.
That's great.
So yeah, originally I wanted to use Swift types in C++, like Swift : optional, Swift : array, Swift : all of those types. But it turns out that using them in C++ and then using C++ from Swift kind of breaks everything.
Okay.
So you have to choose one route. Either you only use C++ types in Swift, or you only use Swift types in C++. And only using Swift types in C++ did not work because of this generated header. There were some issues with it. So I opted for only using C++ types from Swift, which is weird because now you have to, instead of use, for example, double question mark is what you do in Swift as an optional double. Now you have to use std dot optional underscore double underscore. So it's like all of those generated types that I now have to use. And there's so many gotchas here because, for example, you cannot create a std optional in Swift. There's no way. You cannot create it. So I need to create or auto-generate a function, a C++ function that can generate an std optional from std optional double from a double. So I have a double. I now just want to wrap it in an optional. This is not possible from
Swift.
You need
like a factory.
I need a helper function in C++, even though the constructor can already do it with the std optional. So this function, you have to look at it. It's literally just returning the double because it's boxing it in an optional. C++ can do this.
Okay.
But Swift cannot do this.
Interesting.
So I have to create this helper function and then call it from Swift. And then I need to obviously also wrap that code, when you need an optional double. Nitrogen generates this code for you where it checks, okay, is the optional does it contain a value? If yes, we create an optional with that value. We call this C++ helper function. It's inline anyways, so there's no performance impact.
Okay.
But it's just a little bit of code that I have to generate because Swift cannot do this yet. And the main reason is probably because it's a C++ template, I guess. And Swift cannot use C++ templates yet. Then you cannot use Swift protocols from C++ because a protocol, I don't think it exists at runtime, a Swift protocol.
No idea, but
so I have to create a separate Swift class that wraps the protocol. So if I have a protocol like device info protocol, and it has get name method, right?
Yeah.
A protocol is like an interface in Java or even an interface in TypeScript, right? Just a spec, and you have to implement it somewhere else. So you cannot use this in C++. I cannot pass around instances of this protocol or interface or top level abstraction. So I have to create a separate Swift class, a well-defined class, which takes this protocol, because in Swift you can use a protocol. You don't care about where it is actually implemented. It's just a protocol or interface. And then I generated all of those functions again. So get name again. This time it just calls the protocol's get name function, returns it. That's it. Just wrapping it. Now it works. So yeah, it's all inlined, luckily. So there's no performance impact for all of this. And obviously, it's still faster than most of the other alternatives. But there were a lot of gotchas and a lot of...
Curious if those cases that you just described will be kind of handled, in the future, because Swift interrupt is kind of fresh and it needs like those edge cases to be found. So curious about that. Maybe you will inspire, Apple or whoever maintains that. I'm not sure, but
I think it's the Swift compiler team. But yeah, it's going to be really interesting because all of those improvements that Swift will land. I can just drop code from Nitro and just make it more simple over time, which is a great investment in my opinion.
Okay.
And then I think the one more really interesting thing is that people don't tend to think about, because in JavaScript you just pass around closures or functions, anonymous functions, and that's it. Dude, the amount of effort you have to put into passing a Swift closure to C++ is insane.
So it's not as easy as in JS. I just put it there, it works.
Absolutely not. So to pass a C++ function to JS, it's pretty easy because JSI has an API for this. But to pass a Swift function, anonymous function, right? You create a lambda to C++, I have to actually allocate a class called closure wrapper. It has this specific closure in Swift. I allocate this type. I convert it to a void pointer, so just a memory address, right? So I don't have the reference to it anymore. I increment the Swift ref count by 1, so Swift doesn't delete it anymore when it leaves the function scope. Then I pass this to C++. In C++, I take this void pointer, have a dedicated Swift method that can call a void pointer anonymous, And then once you call it and wrap it in a std function in C++, once you call this std function, it goes into Swift again, unwraps this void pointer, dereferences, removes the reference count, calls the closure, and then returns the result to C++ again. So it's just, and you also need a context.
That sounds very straightforward.
Yeah, it is.
So you did cover that part, so we don't have to care about it anymore.
Right, yeah. Mm-hmm.
And this is what great people do.
Thank you.
Thank you, Mark. Thank you for doing that. And I have to say, I'm not surprised that those gotchas were mostly C++ related.
Yeah.
After all, we did talk about this briefly after conference, but your repo is like, 50% C++? Something like that, right?
Yeah. I think it's 44% C++, and then a lot of TypeScript code as well. Yeah.
Exactly, and so that's why, right? You had to deal with so much native code again, so that we don't have to. So you guys, if you will want to contribute to this library, think twice. But then definitely it's a good way to discover all those Swift interrupt goodies and how it works, because this is the first bigger project that I hear about using this technology.
Yeah.
And so it's a good example of how to properly use it probably. All right, Mark, let's move on. So let's say I'm building a new project, right? I don't know, client comes in, they say, I want to create this kind of app, and I need to decide. I know that I will have to build native stuff around it for sure.
Mm-hmm.
So should I just start off with Nitro Modules, or should I do some more thinking about it? Like, when should I use it in a project? Like, I'm talking specifically about the fresh project, because migration is different topic.
Yeah. Well, obviously, my opinion is you should always use it.
Boom, started. All right, next question.
Because I'm also doing the same thing, right? I built it because I figured that this is the best way to do this, right? To build Vision Camera and to build all of these other libraries, even if it's just a simple library.
Mm-hmm.
I still think that Nitro provides the best APIs right now, at least, to build those modules. There is one thing that I could still, improve a little bit on Nitro, because Nitro makes assumptions that you know a little bit about native code.
Mm-hmm.
Not too much, but you just know how to build setup and stuff like that, right? So, for example, in Nitro, there currently is no template to create a library, or there's no, there is a template, but there's no easy script to just use it, right? So you have to pull it from GitHub and replace the code yourself.
Mm-hmm.
So it just is a little bit of effort right now, but this will definitely mature over time, maybe in the coming weeks or something. So, just getting started or getting Nitro integrated in your project is a tiny bit of an effort compared to just an Expo module, for example, where the developer experience is just like you create it and it works.
Mm-hmm.
So Nitro is the same. It also works, but you have to do one or two more steps.
Yeah. Look, it was just released, right? Let's give the community some time to come up with the best DX, and we'll be good. Because Expo, it has a great experience, but Expo as Expo in general, they started by defining we want a great developer experience first, because when they were kind of becoming what Expo is, like React Native was not that easy to work with, and it was pain in the ass to set it up and everything. So Expo was starting this. So this is justified, right? It can have, not a great DX right now, the Nitro modules, because it has great stuff beneath that. So that's fine.
Yeah. But I think it's to maybe scope DX a little bit more. Developer experience in Nitro is amazing. So, I talked, I built with Mike from your team. I worked with him the past days, and he was like, Nitro, it's amazing. I never want to use anything else anymore, right? You just write your TypeScript spec and then implement it in Swift. It's like 20 lines of code in Swift to do the same thing in way more lines in Turbo or Expo.
Yeah, Mike was really excited about Nitro. So I was actually trying to convince him to join us today, but he was busy, I guess. So too bad. But he can definitely tell you guys more about it on Twitter or on X, because he's really excited about it.
Yeah. So the DX of actually building something with Nitro is insane. I think it's the best DX right now. It's just so logical. With the example I gave before, the synchronous function, you return a promise, just like JavaScript.
Mm-hmm.
Everything is just like a JavaScript class, but just a native class.
Mm-hmm.
So I think the developer experience when building something with Nitro is unmatched with any other libraries with Turbo, with Expo. But the developer experience of getting Nitro installed first or get it or build. Sorry, Nitro. Installing Nitro is easy. You just npm install. That's
Yeah.
So that's the core runtime in C++. But installing or creating a Nitro module yourself, you just need, this nitro.json config, and then you need to figure out how to actually autolink it, which I think is very straightforward. But there have been some people who, I don't know, had some weird setups, some monorepos where, the path just didn't work. So they needed to change the path on their end, but they needed some help to get started.
Yeah, but that's why I asked about the fresh project, right? So you don't have to really care about it. Because for big monorepos or projects that basically consist of millions of lines of code, you probably will struggle with anything new trying to add to it, because usually the setup is just so complicated.
Of course, yeah.
Okay, so that's great. Now, if I have a project with Turbo modules, let's say, and I don't have like huge performance issues or anything like that, should I consider migrating or not worth it? Like what would be for you the signal that, hey, this might be actually migrated and it might benefit from this migration?
So I think if you build a library where you think you had to hack around some limitations of Turbo or Expo modules, or even use JSI, if you build a library and you had to use JSI or you use JSI, I think in all of those cases, Nitro will solve all of those problems for you.
And that's a great, very simple sign, right?
Right. And then, but also for simple libraries like the device info module that I gave the example before, it makes sense to migrate it to Nitro if you're bored. It's not going to improve your app's performance by a lot, because it's just a simple, the device info.get system name function. Frankly, it doesn't matter if it's like 1 microsecond or 2 microseconds, right? But obviously, for Filament, for example, where each render frame function does like 200 calls to the native side, and then you run it at 120 FPS on your phone, that is going to make a big difference. Actually, it's going to be, almost night and day if it's smooth or not smooth.
Okay.
But yeah, so if you have a simple function, a simple method, a simple module, you might still find Nitro, a breeze to work with, because the APIs are just so cool, with like the promise return with properties instead of functions, read-only properties. So just getters instead of a get method, which just looks cleaner. It's Swift, it's Kotlin. So I guess in this cases, you can migrate. There will not be a noticeable performance gain, but it's a nice API and it's, newer technology, and you will be able to use this in a non-React Native project as well in the future. Maybe with Native Script, for example, if they have JSI, you can maybe just build it and use it anywhere.
Awesome.
So that's the other bit.
All right. That's I like these guidelines. They are very straightforward, no bullshit. You just know when to do that and when not to do that. I love it. Okay. So, as we are slowly heading towards the end of the episode, since the release, it's been like almost a month ago, not fully a month ago. Did anything big happen to Nitro modules? If people did like check the release and now they are listening to that, would you let them know about something new?
Yes.
All right.
Of course. There's actually many things, or not many, but multiple big things that happened since the initial release of Nitro, which is, and I want to clarify one thing. Nitro, is split into this core C++ library, then React Native Nitro Modules. This is one core C++ library that powers React Native Filament. It also powers React Native Web GPU already.
Oh, nice.
So big libraries using it. And it has not been changed since a long time. So it is stable. I would call it stable at least. There have not been any, real changes to it, because it's working and it's very flexible and you can extend everything. It's just there. It works. It's a C++ library. It does everything you expect it to do. So there was only one change in the past, half year or something, which was a non-breaking change, because it just migrated from host object to native state.
Okay.
But in the code generator, which is what you're using to build Swift and Kotlin modules instead of C++, there were a lot of major changes, non-breaking changes, obviously, but a lot of major new features. So, for example, last week I added variant support to Swift and Kotlin, so you can actually use a number or string in Swift and Kotlin, which is pretty cool in my
Just
opinion.
like we do in TypeScript.
Right. I wouldn't recommend it because it is a runtime type check. Obviously, you need to find out, okay, is this now a number or a string that I'm receiving? So I wouldn't recommend variants, but they are supported.
Nice.
And there's a performance guide actually in the Nitro Modules documentation. So if you want to read that, there's a bunch of tips that you can, read through.
Here in Callstack, we really like performance guides. So
I know, yeah.
we need to check that out.
I know. Yeah, one's I'm getting off track a little bit here, but one specific thing I really like about this is, for example, imagine you have a database library, like, some SQLite library, and you want to return a data set. Okay, let's say you return, SQLite is a bad example because you can filter with where clauses, but just imagine you have a database where you receive a lot of data and you in JavaScript now want to filter it. For example, you receive a huge data set of users, but you only care about users who live in Vienna.
Yeah.
Okay? So now instead of returning 10,000 users to JavaScript, which is what you do in Turbo Modules or Expo, I guess. I don't know if maybe they have an API for that. But in Turbo Modules, you return 10,000 users to JavaScript, and then you do for const user in users or users.filter or something like that, where city equals Vienna, right?
Yeah.
The problem with this approach is that and then you only like 20 users live in Vienna, okay? The problem with this approach is that you had to return 10,000 users to JS, parse everything from a native, user instance to a JavaScript user object. This is a lot of effort for 10,000 users if you only use 20 of those. So what Nitro allows you to do is to optimize differently. It's not just faster by default, which it is, but it's also allowing you to optimize a bit more efficiently. Instead of returning 10,000 users directly, you can return some kind of result hybrid object. So it's a native object that contains the result on the native side still. And then on this result object, it's still not converted the users to JS, right? On this result object, you can do in JS .get all users where city is Vienna, some kind of filter function or whatever you want to do. And then it only converts 20 users to JavaScript instead of those 10,000 because it's kind of like a proxy object that's returned to JavaScript first.
Okay.
So it allows you to optimize differently.
But let me just understand it. This function that you mentioned for filtering is something that you as a library developer would have prepared, and then user from JS would just use it. Okay.
So you could create a filter function, and you can even take a callback for this. But then again, you're converting the stuff to JS again. So it allows you to optimize differently. If you know your data sets, if you know what your use case is, you can optimize more efficiently, like, only filtering the users that live in Vienna.
That's pretty sick.
Yeah.
But where is this data stored then? Like if I keep some data in my Nitro module, right, as you just mentioned, where is it stored? Is it just device, but is it just the device memory? Like, is it safe to keep this data there?
Yes.
Okay, that's what I'm asking.
So if the result object in JS gets deleted, it will just automatically also delete your Swift, Swift instance.
All right. So it's like a cache for a time of using that specific site.
I think cache is already complicating it because it's just an instance in memory. That's it. Very simple.
Okay, just like that. Like in a variable, we keep the data. That's
right. And so that's one thing where Nitro allows you to optimize differently.
All right.
Anyways. Okay, a bit off.
That was very interesting. So I have to clarify.
Yeah, no, I think that's something that people are kind of missing. Like, for example, for the vision camera frame, this is JSI anyways, but if you receive a frame from vision camera, in almost 99% of the cases, all of our clients, all of our, all of the people that we work with, they just pass this frame again down to native. There's no need to access anything on this frame in JavaScript for most cases, like frame.width, frame.height, frame.array buffer. So we don't need to actually convert anything to JavaScript yet. We just need to pass the instance to JavaScript, and it's just going down to native anyways.
Okay.
No need to eagerly convert width as a number to JavaScript number, height as a Swift number to JavaScript number. So this is what this hybrid object approach allows you to do. It's just a native property that is only converted to JavaScript when you access it.
That's pretty performant though, because if you deal with especially big sets of data.
Yeah,
and then you have to still kind of render it as well and do stuff like that. When you think about these cases, it's kind of impressive, this approach.
There's actually many real-world use cases in the libraries we have today. So, for example, in a React Native Gallery or React Native Media Kit, whatever library, some of those libraries return an image. If you request an image, right, find image with ID, whatever, you get the image, you get the path, you get the width, the height, the orientation, whatever. And then many have also have a thumbnail base 64 encoded, right? Even if you don't access this, it encoded it in base 64 and returns the large string of the thumbnail. So, for example, in Nitro, you don't need that. You can just add a method, get base64, and only if you actually need the base64, it will convert it and send a string to JavaScript.
That's pretty awesome.
So only access the data that you actually need. This is what hybrid objects are about. It's very obvious, right? If you think about it from a native perspective, it's very obvious. You don't need to convert everything eagerly, right? But it was not so obvious in JavaScript because the interfaces were just not there back in the day.
And this is very handy.
Right. So back to the original question. Sorry, I got a little bit carried away here.
It's fine.
Many features. Variants are one thing. I improved the documentation a bit on synchronous versus asynchronous functions.
And those sick designs.
Yes, we shipped a great designs. Yeah, so amazing redesign for the documentation. This looks really, really sexy. And then one more really cool feature is the inheritance, which I shipped yesterday. So you can actually create inheritance for hybrid objects.
And how, like, what's the syntax there? Like, is it a familiar syntax or is it something new?
It's a completely familiar syntax. I'm glad you asked. So you just say, interface blah 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 extends hybrid object, and then it's just a what do you call it, comma, and then whatever it extends otherwise, just another type. So that's very obvious. It's just how inheritance works. Types are perfectly set up. It does inheritance in C++, in Swift, and in Kotlin. So everything just works, and it's pretty cool because there's, for example, for let's say a camera library, you have one common base hybrid object, which is resulting media. It has a save to file function. It has a width, a height, and then you can have photo, which is extends media. Yeah. So it also has the save to file function. And you have video, which also has save to file width and everything. And you have maybe thumbnail, what do you call it? Snapshot picture. So all of those have the same base type. You can use the base type. You can upcast it. You can downcast it.
So I can inherit in my Nitro modules from other Nitro modules as well?
From hybrid objects, yeah.
Okay, from hybrid objects. But
you mean between different Nitro libraries?
Yeah.
Yes, this is something I want to support next. It's only a matter of setting up the namespace correctly. Right. It works in theory. If you have the same namespace, this is what you configure in your nitro.json file. You say, for example, if you build a device info module, you say namespace device info or device.info, whatever you want to call it. But if you have the same namespace, it already works. And different namespaces is just a change I need to add to Nitrogen so that it actually finds the namespace per hybrid object. But yeah, this already in theory works.
Nice. So we are already going into future, just improving the DX, basically.
Right, yes.
Sick, man. Okay, so...
And then, sorry, one thing, because you mentioned cross, Nitro modules or cross-module, cross-library boundaries. This is also one thing I think is very, very interesting. Let's say you have a camera library and you have the take photo function. It returns a photo, right?
Yeah.
As of today, it writes this photo to a file. So it saves it to a file. And then you get a JavaScript simple object with height and path. Okay. Now, if you want to display it in an image immediately afterwards, like the Snapchat use case, you take a photo and display it.
Yeah.
You actually have to mount an image component, has the path to it, and the image component loads the image from the file again.
Yeah.
Why? Why do you need to save it to a file if you're going to read it immediately again? There's no reason for that. It's slow because you have to write and read from a file, and it increases disk storage because you have to write to a file. So in Nitro, for example, you could create a image type, image hybrid object. So take photo, returns an image. It's still in memory. It's just an image instance, a Swift image in memory, no writing to a file, and then pass it to an image component that also uses this image type. And you can immediately display this image without writing to a file. It's faster, more efficient, more straightforward. It's very obvious. In a native iOS app, you would never write to a file if you read it again immediately.
Yeah, exactly. You got a blob or base64 or whatever, right? And you use that.
Right. I mean, for images, no, you don't use a blob or base64 in a native app because there are some different image types, and encoding to base64 is an overhead, for example.
Oh,
so you just pass the image instance, like it's a UI image, for example. You set it on the image view. That's it.
Right.
So much more straightforward, much more performance, and much, cooler. You don't need to write it to a file. You just return the image, and then the user can optionally save it to a file if he wants to. You can add a method to it, like save to file. That's it. So yeah, and in theory, if I add this namespace support, you would also have the option to, for example, if the camera returns an image, or let's say the image component has this image hybrid object, in the camera, I can just use the image hybrid object from a different library. That's it. So I think this is really, really cool, and allows you to build much faster apps if the image is just in memory. If there's many ways you can optimize with this.
Sick. That's actually pretty sick. Now you just kind of like, blew my mind. That was a great addition, because I think many people don't even consider this kind of things as the new approach. But there you go. It just works.
It's instance-based stuff. Yeah.
All right, guys. So I got one more question because we are tight on time. So one more question from somebody from Twitter. They were curious. I got two questions. I'm gonna let you choose. Choose number 1 or number 2.
Number 1.
All right. So, how can we optimize performance with Nitro Modules when handling complex media operations like real-time video editing or processing in React Native?
Yeah, I think this is the previous explanations on hybrid objects is already covering this part. So I think this question is partially already answered. So you just have each frame or each segment of a video could be a hybrid object. You just pass this around and then that's it. You can also have Nitro also has a .close method. You don't really want to use it, but for real-time use cases like vision camera, for example, you might want to eagerly close the frame after it has been processed. So
there you go.
Yeah, I think that answers the question. Maybe we can do the other one as well.
Sure.
If we have time.
Because it was super swift.
Yeah.
Swift. What are some strategies for minimizing the overhead when passing large amounts of data between the native side and React Native using Nitro Modules? You kind of answered this one as well.
Yeah. It's kind of already answered. Yeah, maybe I accidentally answered both of them. So yeah, you just you can optimize by lazy getting data. So you just return a hybrid object
and implementing your filter function.
Right, the filter function. Or for the first question as well, you have the image and you don't need to base 64 or anything if you real-time encode it, right? So you have, everything is natively implemented, lazy, only process when you actually call it. It's very, very straightforward approach how you would just build a native app. It's not, there's no workarounds anymore, where we had to do some workarounds to get data from natives. Now it's just, expose the data, that's it.
So to the question that's sound true, the is simple, just implement man. Because now you can.
Yeah. Yeah, buffers and stuff like that directly. You can expose a native buffer to JavaScript.
Exactly.
And so there's so many ways that are very obvious for a native developer. But, now we also have them in
Awesome.
JS.
All right. So as a wrap up, let's have a word or two about the future of Nitro Modules. So I know that there was you were talking and stuff. I know that there was I don't know if discussion or request or whatever that was, but to add the template to BOB. So yeah, can you share something about that?
Yeah. So I think for future, I think the core library of Nitro is pretty much stable. There's not going to be many changes in the core library, except, maybe at some point we want to use Hermes FFI directly, the C APIs to make it even faster if we want to. But this is stable, so I don't think there's going to be many changes to it in the future. Just minor improvements, I guess. But, there's it works. Then template. I want to, get people who are also not familiar with native code onboarded more quickly, because at the end of the day, you just have to write Swift and Kotlin, and frankly, it's just much easier to use than Objective-C.
Yeah, 100%.
Right, and obviously C++ as well. It's Swift is easier to use than C++.
Yep.
So the template, to get new people or new developers or people who are not familiar with native languages onboarded more quickly, I guess. So you can bootstrap a template and you're immediately there. You have your Nitro module. That's it. That's one thing. And then to BOB, it would be awesome, for the CLI as well, to be able to auto-link Nitro modules directly, because right now every Nitro module has to be a React Native library by design. And the React Native library is empty, so there's no runtime code. It's just for the CLI to trick it to think, okay, this is a library, I want to link it in the React Native project, but then there's nothing to link, so it just links the Nitro module. So I'm just kind of tricking it, which is not. It sounds like a private API, but it is not a private API. It's just just a stub, and it just runs my code instead of I guess the Turbo code. So this is one thing that I want to add, just a more straightforward approach to just, allow React Native CLI to just detect Nitro modules directly and link that.
All right.
Template as well, to create an app. or a Nitro module with an example app directly, which will be much more, like a very simple template. And then what else? Yeah, and then there's going to be many libraries using Nitro. I already have, Filament is already using Nitro. Vision Camera will hopefully use Nitro in the next weeks or so. I need to migrate it. React Native MMKV, React Native Web GPU already uses a prototype of Nitro, and they want to migrate to the release version now. But I sent William the code a few months ago, and he just used it, and it's working fine for him. So I guess that proves how stable it was already back in the day.
Nice, that's a flex.
Yeah,
that's a flex.
And then, React Native Unistyles uses it, and React Native Video, they want to use it for view components as well. So yeah, view components is also one thing where I want to add first-class support to it, to kind of interop with the React Native way of dealing with views, because right now you have to work around it a little bit by kind of doing a little bit more boilerplate yourself. But I think I can do a lot of that heavy lifting, I guess, for library developers. But the guys from React Native Video, they're smart, so they figure that out. And yeah, many other libraries, many big libraries that want to use Nitro, because they, as library developers, just see the benefit in this more straightforward and more performant approach.
Do you know if React Native Vision OS is also considering that? I don't know. I need to ask Oscar, but
I don't know. Yeah, I also need to ask Oscar.
Yeah,
I can definitely help him get started. It's very straighthtforward, but I can help him get started.
So Oscar, if you're watching this, hit this guy up.
Yes, hit me up on Twitter.
All right. So I think that's it. I mean, we could stay here. We have skipped a few questions, guys, so you don't have to stay here for hours. But we can definitely catch up at some point if there will be any new releases of this library. We can try to catch up. Maybe we'll have something new, maybe some different use cases of Nitro already. So, let's keep in touch. And thank you for joining us today. Guys, that was Marc Rousavy again from Marcello, and he was talking about some great stuff about Nitro modules. So, Marc, thank you very much.
Thank you for having me, yeah. And if you guys want any updates, just follow me on Twitter or X or whatever it's called now. Yeah, thank you.
There you go. Thank you, guys. See you in the next one.
Ciao.